Okay, so in this video, we're going to be talking about trig ratios and we're going to be doing application problems, meaning we're going to be doing word problems. Now, I have a whole video on trig ratios, so if you don't know how to do them, make sure you check out that video. I'll go ahead and link it below. But assuming you know how to do this stuff, let's go ahead and look at our first example. And again, it's a word problem. Now, before I get into this word problem and the other word problems that we're going to come across in this video, you have to know a couple of things here. And that is, what is the angle of elevation and what is the angle of depreciation? So for example, if you had a horizontal line, your angle of elevation would be right here. So I'm just going to go ahead and put angle of elevation. I'm going to go ahead and abbreviate it. So AOE, angle of elevation. And then your angle of depreciation would be right here. Okay, again, I'm going to abbreviate. I'm going to say AOD. Okay, angle of depreciation. So those are two things you're going to have to know in this video. Other than that, you just have to know the trig ratios. So let's go ahead and take a look at our first example. And let me go ahead and get rid of this here. It says a lamppost casts a 12-foot shadow and forms an angle of elevation of 35 degrees. How tall is the lamppost? So again, we know that it has a 12-foot shadow. Let's go ahead and put that on. Okay, here's the shadow. And we're going to put 12 here, right? 12 feet. So here's my lamppost right here. And again, it doesn't have to be perfect. I'll go ahead and just put a light right here. There you go. And now the angle of elevation is going to be right here. Okay, to the top of that lamppost. So I know that the angle of elevation is going to be 35 degrees. So I'm going to put 35 degrees here. Okay. And what are they looking for? Well, they're looking for the height of the lamppost. So I'm going to go ahead and put H here. I don't know what that is. And now you have to go back to your trig ratios. How can I figure this out? Well, here's the angle in question right here, 35 degrees. And think about the three trig ratios. You have sine, you have cosine, and you have tangent. So if you think about sine, sine is opposite over hypotenuse. Well, that's not going to help me because I don't have anything here on my hypotenuse, right? Cosine is adjacent over hypotenuse. That's not going to help me either. But if you think about tangent, tangent is going to be opposite over adjacent. So I could say here tangent of 35 degrees is equal to opposite, which is going to be H, over my adjacent side, which is going to be 12. And so from here, all I have to do is multiply both sides by 12, and I get H is equal to 12, and then times tangent of 35 degrees. So that's exactly what you're going to plug into your calculator. When you do that, just make sure you are in degrees. So when I plug this in, I do 12 and then times tangent of 35 degrees, okay? And when you do that, you should get the following. I get 8.4. So the height here is going to be 8.4 feet. And again, I rounded to the nearest hundredth here, okay? So there's your answer. The lamppost is going to be 8.4 feet, okay? Let's go ahead and try another example. So here's our next example. It says an airplane is 50,000 feet away from an air traffic control tower. The angle of depreciation formed between the airplane and the base of the tower is 30 degrees. What is the altitude of the plane? So we can go ahead and put on a plane. Again, it does not have to be perfect, but here we go. Here's my airplane, right? Here are the wings. And there we go. There's the airplane, right? And we know that it's going to be 50,000 feet away from the air traffic control tower. Why don't we go ahead and put that tower on? And I'm just going to draw it like this, okay? Doesn't have to be perfect. There's my tower, right? Okay, and now we know that the distance from the tower to the airplane is going to be 50,000 feet. And so what I'm going to do here is just draw a vertical line going down, okay, from the airplane. There we go. And then I'm going to draw on the horizontal distance, which we know is going to be 50,000, right? So 50,000 feet. There we go. And then it says the angle of depreciation formed between the airplane and the base of the tower is 30 degrees. So you have to picture a horizontal line going from this airplane directly out in front. So for example, you could have a horizontal line like this here, okay? And then the angle of depreciation is going to be formed from my airplane to the base of the tower. So for example, right here, okay? So the angle of depreciation is actually going to be right here. And it tells us that that is going to be 30 degrees, okay? So you can clearly see that this whole angle right here is 90 degrees. So I know that if this angle right here is 30, this angle right here has to be 60, right? So I'm going to go ahead and put 60 degrees here. Okay, when I add the 2, I get 90. That checks out, right? And so what can I do to get the altitude of the plane? So here's my altitude right here, okay? Well, think about your trig ratios again. Which one is going to make more sense here? If you look at your hypotenuse, you don't have anything there. So that eliminates sine and cosine. It's going to have to be tangent. So tangent is opposite over adjacent. So I'm going to say here tangent of 60 degrees is equal to, well, here we go. We're going to do opposite over adjacent. So that's going to be 50,000, okay, all over A. And from here, you just have to switch tangent of 60 degrees in your A variable, right? And then you can solve it. So I'm going to say here A is equal to 50,000, okay, divided by tangent of 60 degrees. So again, I'm going to go ahead and plug this into my calculator. I'm going to round it to the nearest hundredth. So let's see what we get here. So I have to do 50,000, and then I have to divide by tangent of 60 degrees, okay? When you do that, you should get 28,000. So I'm going to go ahead and write it over here. A is equal to 28,000. And again, I'm going to round it to the nearest hundredth. And then we get 867. And we'll say 0.51. 0.51. There we go. And again, that is going to be in feet, right? So that is going to be the altitude of the plane, all right? So let's go ahead and try 2 more examples. So here's my next example. It says the angle of elevation from the ground where Dave is standing in the pine tree is 37 degrees. The pine tree is 95 feet tall. How far is Dave standing from the pine tree? So why don't we go ahead and put on this pine tree. Again, it does not have to be perfect, but we'll do our best. So here's my pine tree. I'm just going to draw a triangle on top for the top of the tree. There we go, right? And here's Dave. I'm going to put Dave over here. Okay, there he is. And it says that the angle of elevation from the ground where Dave is standing in the pine tree is 37 degrees. Okay, and so then you're going to have this angle of elevation that looks something like this here. Okay, and then you'll have this horizontal distance here. That's what we're looking for. Okay, so we're looking for this horizontal distance. We'll just call it X. We know the height of the tree, that's going to be 95, and that's 95 feet. And we know the angle of elevation, that is going to be 37. So I get 37. And again, that is degrees. So again, what ratio are we going to be using here? Well, it looks like it's going to be tangent again, right? So if it's going to be tangent again, I can say tangent of 37 degrees. And this is going to be equal to opposite over adjacent. So 95 all over X. Okay? So again, you're just going to switch tangent of 37 degrees and X, and then you'll solve. So you get X is equal to 95 divided by tangent of 37 degrees. Okay? So we're going to go ahead and plug that into our calculator, and we should get that horizontal distance. So when I do that, I do 95, and then I divide by tangent of 37 degrees. Okay? And I get the following. I get 126.07. Again, I'm rounding to the nearest hundredth here. I'm going to say X is equal to 126 and then 0.07. So 0.07, and that is going to be in feet. Okay? So there's our answer. Okay? So why don't we go ahead and try one more example. So here's our last example. It says the following. John is on top of a ladder, and his wife, Sarah, is 15 feet away in the horizontal distance. The vertical distance between their line of sight is 5 feet. What is the angle of depression? All right, so this one is a little bit different, but I'm going to go ahead and draw John, okay? And I'm not going to draw him on top of a ladder. I'm just going to draw him above Sarah, who is below him. So Sarah is going to be over here, okay? So here's Sarah. Here's John. And so how do we go about doing this problem? Well, the first thing that I want to look at is their line of sight. You can look at the horizontal distance. You can go ahead and put that on if you would like, but I want to look at the line of sight first. That way we can get that out of the way. And so we're talking about from John's eyes, which is going to be right here, to Sarah's eyes, which are going to be right here. That's going to be a vertical distance of 5 feet. So what I can do here is I can make a distance from here to the top of John's eyes of 5 feet. So this is 5, right? 5 feet. And then it says that they're 15 feet away in the horizontal distance. So you can think of it like this. Here's 15 feet going from here to here, okay? And so what do they want? Well, they want the angle of depression. So look at this horizontal distance from John's eyes. We know that the angle of depreciation or the angle of depression is going to look like this here, right? Going to the eyes of Sarah. And that angle that we're looking for is right here. This is what they're looking for, okay? And so you can see that I pretty much already have a right triangle. If I just connect it here, here's what we got, okay? So what I'm going to do here is just take this triangle off to the side. That way we have room to fill in our information. So I'm going to go ahead and draw it off to the side, just like so, okay? And we know that, okay, the distance between them is 15 feet. And then we're looking at the vertical distance between their line of sight. That is going to be 5 feet. So here's 5 feet. And we should probably extend this horizontal right here. That way we know that we're looking for this angle, okay? So how do we do it? Okay, well, think about this. I have a horizontal line right here, and I also have a horizontal line right here. And I have a line intersecting both of them. Okay, so if you remember the definition of alternate interior angles, that is when you have a line intersecting two lines that are parallel, okay? And both of these lines, this one right here and this one right here, are parallel. And I have a line intersecting them, meaning I'm going to form alternate interior angles here, which means this angle right here is going to be the same as this angle right here that I already put on, okay? So all I really have to do here is find this angle, and it's going to match up with my angle of depression or my angle of depreciation, which is right here, okay? So again, for this example here, it's going to be tangent again, because I can see here that tangent of this angle, we'll just call it theta, is going to be opposite over adjacent. Okay, so I'm going to have tangent of theta equal to opposite over adjacent. That's going to be 5 over 15. Okay, so they want the actual angular value now. Okay, they don't want a side length, meaning we're going to have to do inverse tangent here. So it's pretty simple. All you have to do in your calculator, we're going to say theta, what we're looking for, is equal to inverse tangent. Okay, so inverse tangent looks like this, and then of your value, which is 5 over 15. So if you're having trouble finding inverse tangent on your calculator, all you have to do is hit second and then tangent. That will give you inverse tangent, right? So if you can find tangent, you can find inverse tangent. You just have to hit second and then tangent. So in my calculator, I'm going to hit second and then I'm going to hit tangent. Now I have inverse tangent on my screen, and I'm going to do of 5 divided by 15, okay? And again, this will give me the angular value. And it gives me a value of 18.43 degrees. So that angle there, theta, is going to be 18.43 degrees. And this is done, okay? And remember, that is the same thing as your angle of depression because of alternate interior angles. So you can see that in all of these application problems, we were dealing with tangent, which is opposite over adjacent. But again, you could do this with sine and cosine as well. It's just the ratios are going to be a little bit different. With sine, you have opposite over hypotenuse. And with cosine, you have adjacent over hypotenuse. But it is exactly the same process, okay? So that's it. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel that we get more math videos in the future, and I'll see you in the next one.